Welcome, y'all. We're going to start our new chapter in chapter 3. All right, so we're talking about parallel lines and transversals. Let me go fix that. There we go, transversals. For some reason, want to come up. Now, if you look right here, we're looking at a more three-dimensional world setting where we got lines at top, lines at bottom, and this will be an example we'll refer back to here in a bit. So let's kind of talk about lines in general. So two lines don't intersect in two different ways, what we call parallel lines. For example, lines that run in the same manner on the same plane. So they're coplanar. They lie on the same plane. And they never intersect. So they'll extend forever, infinitely that way, infinitely this way, and they will never intersect with each other. You probably mess with some of these right here in algebra when we're talking about slope of lines, as we'll talk about later. And then there's skew lines. It means they're non-coplanar. They don't exist on the same surface. For example, it looks like this is happening through, but this is actually on the actual surface, and this one right here is going through it. This dotted line, it means we're seeing through this plane underneath it. It is running through it. So it's like a wall that runs up and down, and then one that might be diagonal. That's why we refer back to this. This will extend forever that way on this surface and forever this way on that surface. This will go this way, but if in the grand scheme of things, it's running right above it. They never intersect. They may look like it right here, but there's no actual intersection happening right here. That's what makes them skew. Skew lines do not exist on the same surface, and they never intersect. Sometimes things cannot exist on the same surface. For example, this line right here and one, if I drew one across and it intersects that right there, they intersect. That can happen. But these particular ones right here, they're skewed because one, they do not intersect, and two, they're non-coplanar. So if maybe on the test I happen to say, hey, what's a skew line? The two things I'm looking for is non-coplanar lines that do not intersect. All right, so let's talk about what happens with angles. So transversals, and this is for coplanar lines, so whether they're parallel or not. Now, we bring in this format right here. In the next lesson, we'll talk about the exact same angles. But these angles exist not because of parallel lines, but because of where their positions is at. So a transversal is the line that intersects two other lines. So for example, you can bring in a third line if you want to. This is still a transversal because it's intersecting the two other lines here. Let me see if we can bring this up like that. There we go. All right. So a transversal is the line that intersects two or more. So this is a transversal right here. Okay. Now, when this happens, we have two sets of lines. We get what's called interior angles. So angles on the inside. So in this case, that's our 3 and 4 and our 5 and 6. They exist on the inside of all this. So we're going to shade that just so it kind of makes it. So we'll say highlighter. There we go. Interior angles on the inside. So anything that exists inside. So in this case, there's 4 angles. 3, angle 3, angle 4, angle 5, and angle 6. So 3, let's change the color on that. There we go. Angle 3, angle 4, angle 5, and angle 6. Right there. So those are our 4 interior angles. Exterior angles are angles that exist on the outside of this right here. So in this case, outside. So 1 and 2, 7 and 8 in this case. 1, 2, 7, and 8. All right. Consecutive interior angles. Now, hopefully you wrote this down. I'm going to clear it out real quick. Clear annotation. There you go. If not, go ahead and rewind that. Let's try that. Let's look at consecutive interior angles. Consecutive interior angles. There we go. Consecutive interior angles are angles that are interior. So it's 1, 4, 5, and 6. But they're on the same side of transversal. So in this case, this is the same side. So 3 and 4 is 1. And then 3 and 5, sorry. And 4 and 6 are 1. This will be very important later because consecutive interior angles have a certain representation to each other, a certain meaning to each other in parallel lines. So we talk about parallel lines. This is not true yet, but this is just a position. So what matters is these positions are true regardless of their parallel lines or not. All right. So let's kind of move on from here. Let's talk about alternate interior angles. Let's dissect that word for alternate. Alternate will be opposite. Interior meaning inside, angles. So opposite interior angles. Now opposite of what is the key word? Two non-adjacent angles. So they're non-adjacent. They can be next to each other. Interior angles opposite sides of the transversal. The transversal is the important part. So we'll do this in the same color. Alternate interior angles. So 3. What is opposite of the transversal here will be 4 and 6. But remember, non-adjacent angles, that's also interior, it can't be 4 because this is adjacent, right next to it. So its opposite interior angle buddy will be down here, 6. So then 4's opposite interior angle buddy will be opposite of the transversal, but not next to it. It'll be this 5 over here, okay? That's important to see. Just like there's opposite interior angles, alternate interior angles, there's alternate exterior angles. So same format, non-adjacent, exterior, opposite side of the transversal. So 1 will be alternate exterior to 8 down here. Yeah. Right there, good. And then 2 will be alternate interior to 7 down here. All right. So make sure we got this down. Alternate interior, alternate exterior. Make sure we know where those are at to each other. Last one, I'm going to clear this off, so make sure you kind of write that down. Last thing right here is corresponding angles. Now, the word corresponding, the way you've seen this before is like in news anchors. News anchors are corresponding to each other, meaning they're doing the exact same job somewhere else. So corresponding things are the exact same thing, just on a different location. So here, 2 angles in corresponding positions related to each other, but on different lines. So they're in the exact same spot, just on the different group of lines. All right, so sorry about that. All right, so corresponding angles, like we said, 2 angles in relatively the same position as each other, just in different groups. We got 1, 2, 3, 4, 5, 6, 7, 8. They all have a corresponding partner. So for example, angle 2 is a top right angle in this group right here. So its corresponding partner down here will be angle 6. Those two are corresponding to each other. 1 will be to 5. 3 will be to 7. And of course, then 4 will be corresponding to 8 down here. So kind of match the colors right there. There. In the next section, as we'll talk about it, those will be these particular angles in these particular spots will be congruent to each other. So right now, we're just talking about their positions right here. They're named these because of their position, not because of their value. So let's kind of put all this together and try that. So we're going to name are these alternate interior, alternate exterior, corresponding, or consecutive interior. So start with 5 and 15. So we're talking about angle 5 right here and angle 15 right here. So if we look, we got to figure out there's a lot more lines than normal. We got angle 5 right here. I'm going to just circle it, and angle 15. So in this case, what is the transversal and what's the 2 lines to be intersected? We have more lines than we need. In this case, C will be considered transversal because it's the line that travels between the 2 angles. And then A and D is the other part that makes this angle. So for example, angle 5 is made up of line C and line D. Angle 5 right here is made up of line C and line A. So, all right. So now that we know what's the 2 lines that are being cut by the transversal, what are their positions to each other? Their position to each other, they're both they're opposite sides of the transversal, so they're alternate for sure. Alternate. Now the interior angles exist between the lines or exist outside lines. They're exterior, alternate exterior angles. Or the shorthand for this would be alt exterior angles right there. All right, let's look at the next one. Let me erase this. All right, next one, 11 and 17. So there's 11 right here and 17 right here. So the 2 lines, the transversal in this case will be B. This is a transversal. It travels between the 2 angles. And then there, we got B and C. And then we got B and D. All right. So looking at these two lines, are they interior or exterior angle? They're for sure interior. They exist between the two lines that are being cut right there. And they're on the same side of the transversal. So this is what we call our consecutive interior angles. Another thing I forgot I kind of mentioned, these are also called, consecutive interior angles also called same side interior angles. So they replace this word same side and consecutive back and forth in different books. And I think in this book too, they'll sometimes say that. So these are consecutive interior angles, or you just say consec interior angles. Either one. All right. Good. All right, you guys make sure you're trying this on your own first before I name them. So let's look at 13 and 8. 13, which is right here, and 8, which is up here. All right, so they're both made up of, they both have C. So that means the transversal angle 8 right here is made up of side line C and line A. Okay, this is made up of line C and line D. All right, so transversal wise, they're on opposite sides, so they're alternate. Okay, let's set alternate. There you go, alternate. Are they in between the two lines or outside the two lines? They are in between, so they're interior. Alternate interior angles. Good. You guys are doing well. Let's look at the next one right here. Next one, we're looking at 14 right here, and 6 up here. Good. So they're both made up of C, and this one, angle 6 is made up of C and A, so it's C and D. Good. So are they on the same side of transversal? Yes. Okay, they're same side. But are they both interior? No. One's an interior angle. What's an exterior angle right there? That's what we call our corresponding angle. Corresponding angles. They're both, one's interior, one's exterior in this case. So our shorthand for this would be corresponding, CORR, angles, like that. All right, good job, y'all. Last one right here. Kind of try this out. Last one. Last one says, we're looking at angle 1 right here, angle 1, and angle 10. All right, so they're both made up of B, okay, B, that's our transversal. And then this one's made of B and A, this one's B and C right here. So they're opposite sides of the transversal, so they're alternate. Now, would they be considered in between the two lines, which is this one and this one? Are they in between, or are they outside? They're outside. They're exterior, alternate exterior angles. All right. So hopefully that helps you to kind of see position-wise what they're called. As we move on to 3.2, you'll see their relation as far as value, as far as